Okay, so thank you to Junior Mechanic for the thumbnail. So what have we got here then? So this is a Mitsubishi i-miev. It's fully electric. It is it's not very common. It's quite narrow and quite tall, but it's built as a Japanese K car, KEI, the sort of Japanese city car sort of classification. So yeah, it's they did petrol versions of these, and then they sort of converted them to electric. It's not that common, but I really like them. I think they're quite super cool, really. Kind of bubble car look about them. Yeah, it's broken. So yeah, these cars, test ones came out in 2009, the sort of pre-production test models. Yeah, they weren't really available to buy until about 2010. So this is basically one of the first ones that you could actually go to Mitsubishi and buy. Lots of the early ones were leased to companies. They were horrendously expensive, something like the best part of 30 grand. Yeah, I think they're really cool. They drive really nicely, kind of go-kart feel. They're quite basic, but yeah, they go really nicely. So yeah, so Citroën and Peugeot also branded these, so produced the Peugeot Ion and the Citroën C0. They were made by Mitsubishi, sort of came out of the same factory, but with their badges on, so you see some of them. They're not that common, but yeah, but I've basically had loads of them. I've owned about 10 of these for repair, as in bought them with faults, fixed them, run them for a while to make sure they're okay, and then sold them on. And I've also fixed a few common issues for other people on these as well. So yeah, so I bought this one. It was a car sales garage, bought a number of cars, and this was one of them. It's a garage that did like used cars, does like small petrol cars. Just got this with it. He said it drove initially. He didn't really know much about electric cars, so kind of left it sitting, and now it won't charge. Kind of won't start, won't charge, which is interesting. So we'll have a look inside in a minute, have a look at the dash. The most interesting thing about these cars, I think, is that because they were available to buy from 2010, and certainly for companies to lease from 2009 as a sort of pre-production test models, cheap test lease for companies, that makes these cars the world's first highway capable mass production electric car. So they were highway capable because you can do motorway speed in this. It's not like a G-Wiz that does 50 or whatever, that's a quadricycle. This is a proper car with airbags. It's got 4 seats because it's quite narrow, but that's just because it's a Japanese K car classification. It is just a small car. But yeah, this is part of EV history, obviously, like a Nissan Leaf, available from 2011, but this beat it. So unfortunately they were really expensive, which kind of yeah, probably put people off, and quite quirky, but I think they're cool. So yeah, a little bit about the architecture of them, really. They're quite a simple architecture in EV terms. There's obviously not much of a bonnet on them. We'll have a proper look inside in a second, but yeah, so the batteries are sort of underneath between the 4 wheels. The control, the motor and the sort of a motor controller and charger are in the boot, or under the boot floor, I should say. Yeah, so the EV architecture, if you're if you work on EVs, some of the connectors on these don't have interlocks, which keeps things a little bit interesting. And if you don't know what that means, then don't play with the orange stuff, I suppose. So yeah, let's have a little look inside and see what it does. So it's in a reasonable condition overall. They can suffer with a little bit of rust, but yeah, the arches are all sort of good and that, so it's done pretty well, to be fair. So what does it do and what does it not do? So yeah, it's quite surprisingly spacious inside, to be honest. Not really surprising it's only got 2 seats in the back, because you just wouldn't fit. It wouldn't be pleasant at all. But quite a cool, I'll try and move back a bit, but quite a cool interior. Yeah, this one's in pretty good condition, so let's see what it does and doesn't do. It beeps because it's Japanese. So obviously turning the key, nothing happens, it's not starting. We've obviously got a warning light there. It's only done 27,000 miles, which is not a lot. And so I've worked on quite a few of these, so there's a few telltales. So you can see that battery light's flashing. This is what normally happens when the battery's dead flat. but it also happens if there's a high voltage battery issue, and that's what I suspect in this car. There's a common issue with the onboard chargers, but in that case you can generally drive the car but not charge it, so not plug it in and charge it, but you would see the battery range remaining. Yeah, okay, it could have been driven till it's flat, but just from chatting to the seller, I think that's not the case. So yeah, I suspect high voltage battery fault. It's not been driven for quite a long time. It's been sat for a while, so that has an impact on what sort of state the battery's in. But yeah, it's 14 years old. I've fixed loads of these, and yeah, I'm basically gonna try and fix this one. So yeah, I guess if people, you've heard down the pub that EV batteries don't last long and then you have to buy a new one. It's like, well, yeah, I'm planning to fix this, and I'm not going to do it by replacing the whole battery because that's cheating. We're going to work out what the actual fault is, do some diagnostics, and yeah, get to the actual fault, replace the faulty part, and fix it. That's the plan. So yeah, next video is going to be diagnostics, so a couple of bits of diagnostic equipment, looking through the live data, fault codes, all that kind of stuff to work out what the fault is. But yeah, this is basically what it's doing. It won't charge, so nothing happens if you plug it in, won't start, and a nice warning light. So there we go, that's the car, and yeah, we're going to fix it. So we'll catch you later. All right, cheers. Okay, so let's talk diagnostics. So I'm going to go for a few different tools. I've got a phone app, I've got a basic diagnostic machine, and I've got a kind of garage spec machine as well. So I'll try and get this one fired up, and this kind of might demonstrate some of the issues with different ways to do it. So if you're trying to diagnose something at home, you might use an app. This is Canyon, which is written for these cars. I've got a Bluetooth dongle, and we'll see if we can get it to connect and see what information we get. So just waiting for it to fire up. I mean, I always find these things are a little bit more clunky. Some of the apps will give you fault codes but no live data, so that's not connected yet because this is red. Just select my device and see what happens. So this one doesn't give you fault codes, but it does give you live data, and it says it's connected, and we're going to see what happens here. So first thing on the left, we've got state of charge 122%. That's not quite right, and the voltage is 6,554 volts. Obviously these are not too good. It says it's connected. Those figures haven't changed yet. Okay, so this is interesting, and this is kind of illustrates one of the problems. So because I've seen this before, I know what that means, but if you're looking at this at home, you're thinking, is that app working? What's happened here? Something's gone mad. So we've got each of the cells inside the high voltage battery along here. So 1 to 88, it's got 88 lithium ion batteries in the battery pack. And this would be the voltage normally, a bit like it showed first. You'd actually have numbers up here. But what's happened here is, if you look here, there's actually 8 there. And that is cells sort of 9 to 16. So what it's showing here really is that the car thinks that module 2 has a ridiculously high voltage, and I know that is definitely what it thinks. But if you're doing this at home, you might think, well, this app doesn't work, or something like that, and that kind of illustrates the issue with these. And this app's actually crashed as well, I think, because these voltages are just completely out of range. It's crashed the app. There are other screens with different information on, but again, the apps are cheap. This one is really good, to be fair, with these cars, but it can't handle. See, it's crashed. It can't handle it, and that kind of illustrates the point, really. Okay, so the app showed us a bit of information, but then it crashed, and yeah, yeah. So some of them. So that one doesn't show you any fault codes. It will show you live data. So trying to diagnose a car just from that, very difficult. There are other apps for different cars that will show you fault codes, but it will just give you, like, ABC 1 2 3. It won't tell you if that fault code is active or not. Won't give you a description for that fault code. So apps really difficult to diagnose from. Okay, so now I've got this Car Salvage machine. This is the first one I bought when I started doing these cars. I'm not sure you can get exactly this generation before. I think they've changed them. And hopefully that's not going to be too blurry. Oh, that's better. But a really functional little machine. And I've still got it. I'm actually going to post this to someone to be able to do their diagnostics. But I just kind of show you what it does. Pick the region. Oh, and I was going to use my auto as well, but I think that's let's just turn that off, because otherwise this battery's going to run out. I think the battery's not too good on the auto. If necessary, I'll come back in a moment once it's charged up. I'll just show you this one. So this is a 2010 machine, a 2010 car. Yeah, so it is now scanning all the different, looking for the ECUs, looking on all the CAN networks. So this machine, this is, I think it's got the model here, but it's a bit dark. Oh, this is an MHM version 1. Yeah, I don't think you can get this one anymore, but just to show you what kind of a basic diagnostic machine looks like. So we can read fault codes. So we got cell voltage low, and we've got 4 codes on here. Cell voltage sensor. We've got active interlock switch. Oh, that is the high voltage battery safety plug. That's got an interlock. So basically an interlock tells the car that it's disconnected. So it's telling me I've got an open interlock. Yeah, and that's correct because it's there. And we've got charge state signal error from the battery management. So let's just show you some data, what this machine can do. So it's kind of a little bit clunky to use, but there's 166 pieces of data we can look at. We can select all, and then we can go start. And then you kind of have to scroll through them, which is a little bit clunky. I think oh yeah, okay. And then you kind of, but I mean, you know, oh, it's 166 pages, isn't it? So you rapidly reach the limitation of a machine like this. If you were using this all day, you'd probably throw it out the window. But for home use on your own car, or if you've got, you know, like a project car you want to diagnose, they're really good. Really good. It's showing you all the live data, the sort of descriptions and the fault code descriptions and all that kind of stuff is really good. And this machine was something like, I don't know, £110, something like that. It only works with Japanese. I think it's Mitsubishi, Mazda, and Honda. I think that's what the MHM is, Mitsubishi, Honda, Mazda. So yeah, you can't. Yeah, obviously, if you've got different vehicles, you might not be able to use it on all of them. But if you've got a fault with a car, or you've got a project car kind of thing, it may well sort of do the business. So that's showing you some of the data. It is a little bit more clunky, but it's not the price of an expensive, you know, an expensive machine. So let's go into BMU, because we seem to have a high voltage battery fault. And let's look at the fault codes. So yeah, cell voltage low, cell voltage sensor, CMU2. Okay. So, and that kind of ties up with what the app showed, because this car has got, basically it's got 12 modules. I know that's not divisible into 88, but it's got 10 modules of 8, and then it's got 2 4s. So modules 1 and 2, or 1 to 10, well no, not quite 1 to 10 actually, because the 2 4s are in the middle, but 1 and 2 let's say are 8 cell modules. So let's now investigate this a bit further. So we seem to have an issue with the cell voltage monitoring on module 2. So let's have a look at the data on module 2. So this is something, obviously we're getting in a lot more depth, a lot more information than the app can show. We just have to kind of go around the houses a little bit, because this machine is a bit more clunky to use, but it's cheaper, you know, it's really good. So what we've got here, so lithium batteries will operate in a range, in this car at least, of about 3.5 to about 4.1. So we've got a maximum 4.03 and we've got a minimum of 2.1. Okay, so that's quite a lot. Let's just go through and see what other data we can get. So you can see it's kind of a bit clunky to go through all the screens. It takes some time. So there's 88 cells. It's got 0%, it thinks. Internal resistance values are good, so that's kind of a health metric effectively. No leak detection. So, this is on BMU live data, isn't it? So, if we go through, okay, so here we've got module 1, and then we've got like ABC, so 4.02. Yeah, all 4.02s, that's good in module 1, and then we'll get to module, so we've got 2.1s for module 2. Now, we kind of get into another bit of diagnostics because, oh, they're all 2.1. Well, that seems kind of weird. Well, from experience, that basically is a default value because we're asking the BMS for what the voltage is, but the BMS is not receiving some correct information from the module 2 circuit board. So within these battery packs, each module has a circuit board, monitors the voltage and temperature, and that reports it back, and the BMS is just giving us default values because it basically doesn't know. But because we've got quite a cool little machine here, what we can do is we can jump down and actually look at module 2 directly. So we are communicating with the circuit board that's sitting on top of that module inside the battery pack, and then that can give us some data. So these are quite simple circuit boards, so they can't give us fault codes, but they can give us data. And have a look at this. So we can see those voltages are jumping around. So what we've either got here is we've either got a battery, like one of the cells, or the cells, some of the cells inside the battery have failed, or the monitoring circuit board on top of that module that's monitoring the temperatures and voltages has failed. Now, it's pretty obvious if you look at cell B there that it's not plausible for a battery to change its voltage like that. You can see cell D there as well. So obviously that is telling us, let's just flip to the next ones, that is telling us what we've got is a monitoring fault here. We've got an issue on the circuit board on module 2, and I've seen this fault before. I've seen it a few times. And so the cells, it's likely are at the same voltage as the other cells in the pack, so there sort of was a 4.01, but the car just thinks they're jumping around all over the place. And if the car gets any implausible information from the battery, then it will show that sort of flashing thing there. So this battery is reasonably full at that level, at 4 volts. Yeah, mostly full. But yeah, but the car doesn't know that. It's yeah, it's kind of not getting a correct signal from the battery. So that's kind of cool. I'm going to see if the Autel has got any juice in it. This is quite an old Autel, but the screen is not all scratched up. So I'll just see if I can turn this on just to show the sort of interface really. Oh yeah, here we go. See how long this lasts. But yeah, the battery's flat apparently. But yeah, just to kind of show, this is the sort of quality of, you know, what you can do. Oh, make that not blurry. There we go. So yeah, like if I go to, where should we go to? BMU, we'll use this for as long as it lasts with 0% of the battery. So I mean, like it shows the 12 battery voltage, which is like 14 volts because this this car's got battery support on. But yeah, we look at live data and you can kind of see the quality of the interface. I mean, it's just so much easier to use. You know, it's just a million times easier than scrolling through on that other machine. Yeah, and we get our 2.1 default values because it's not getting reasonable data. So the other thing on a proper diagnostic machine is you've got active tests and special functions. So active tests, so you can make the car do things for testing purposes, and running certain functions that Mitsubishi built into the ECUs, but that obviously not accessible through the dash or anything like that. So we are going to need some of these special functions when it comes to fixing the car, but just so much easier to use. But obviously this is not a £100 machine. This is obviously very, very different, but a lot more expensive. And to be fair, iCar Soft, who make the little one, do produce better machines. But yeah, just this Autel obviously has a lot more stuff on it. So, you know, if you've got an issue with a fan or water pump or whatever, you know, you can actually kind of make it, you can run the pump or whatever. You can force the car to do certain things. Yeah, it's just what you get on this above the simpler machine. But yeah, obviously this is what you'd use kind of in a garage environment, but it doesn't mean the other one's no good. The other one's really good for home, and both, obviously that showed us what the fault was with this car, so it doesn't mean that the iCar Soft's a bad machine. Just this is kind of just mainly easier to use, and you can do a little bit more in terms of special functions and stuff like that. So hopefully that's interesting. So now we know exactly what's wrong with the car. It needs a replacement circuit board or a circuit board repair, and then that circuit board will need programming to be happy with being put inside the battery pack. It's not kind of coding to the car, it's more just that they work as a set and it needs to know it's now part of this set. So we just kind of just tell it that it's in there, and that yeah, basically just get them to work together as a set, so they're all communicating to the BMS and all reporting, and it knows it's module 2 and all that kind of stuff. Yeah, and go from there. So that is all for now. I will get this car, I need to get it moved onto some concrete so that I can get the battery out, and I'll hopefully do that tomorrow, and we will go from there. All right, cool, catch you later, cheers. Okay, so just a little bit more information if anyone's interested in about the architecture of the battery on this i-miev and the actual fault. So here are some actual cells from a i-miev. Some old ones I took out. These are kind of expanded, as you can see. These are Yuasa LEV50 cells, and later cars had LEV50N cells, which are a slight improvement, but these are the cells. So this is sort of like basically a failed module from this car. So the car's got 10 8-cell modules. So if these were all in this plastic housing and then all sort of together, that's one 8-cell module. So it's got 10 of those, so that's 88 cells. And then some of the cars have got an extra 2 4-cell modules, so like 2 of just this part, making 88. So yeah, either 80 or 88 cells, and they're in a module like this. And then this is the monitoring circuit board, and this is kind of a little extension just to monitor these 4 cells. So the architecture of this battery, so each module has a monitoring circuit board, because the car needs to know the voltages and temperatures and stuff like that. Lithium batteries have to be closely monitored for voltage for safety, and have to be actively balanced. So this module will actually, when instructed by the BMS, will balance the cells, which is basically just means bleed a little bit of current off as it's charging in that like last phase of charging. So the cells which have a slightly higher voltage just have a little trickle of current drawn out of them, and it just enables them to just come back in line. Basically, I know they're obviously the same cells, but just manufacturing differences. They just have a slightly different characteristics, but it's really important with lithium batteries that you keep them in the right voltage range. So we know from our diagnostics that the voltage is jumping up and down. So on these batteries, this board, which is the cell monitoring unit, and there's one on each module, is monitoring that voltage and other things. So if we have a good look at the board, basically this is where the CAN is connected. It's in a CAN network with the BMS, and there's kind of control chip, there's various chips on there, but this one actually monitors the voltages of the individual cells, and also it does a total voltage as well. So you can see the cells are sort of linked together here, so it kind of goes like that, and there you can see from these ones the orientation, so you can see that that's positive up there and then down here. So if you link them together, it's like having all the cells in a long line, but obviously for packaging purposes you put them into modules, and then on here you've got these little screw positions, so it screws on here, and that basically enables it to do the voltage monitoring. So it comes through here, and that's the chip that actually monitors the voltage. So on this car in module 2, that is the chip that's failed. Now an interesting thing on this board is there's gaps here, so you think, well, how can you read the voltage of this cell, because you haven't got a tab here. Well, obviously this one is directly linked with a big buzz bar to here, so it doesn't actually need to here, because if it does between here and here, then it's monitoring this cell, and the same with this one, there's not one here, so it goes between here and here for this cell, and then here and here for this one. So this is the end of the module, so it can use this to do its total voltage, because it does total voltage of the module and individual, and then it will compare those and make sure that they're sort of, you know, the total is the sum of the parts, if that makes sense. Where it looks really weird, it's hard to put these back together because they're kind of squidged up, but this one should, if I just click this off actually, that'd be slightly easier. So that should be there. When it looks really weird is this cell, because you sort of think, well, how does it monitor that one? But you can kind of imagine, if I grab, it's kind of hard to take out, but if you had a link across here and a link across here, as I was saying, because this one is connected to here and this one is connected to here, you actually don't need to use these tabs at all, and it kind of looks weird and you think, well, how would that work? But basically, if it measures the voltage between that point and that point, because that's connected to there and that's connected to there, then it can measure that cell. And then on the end one, it's got both on there, just because of how it ends up, because at the start it's got, you know, just as the way around it is, it's got a link there, then at the end it's got to do both, kind of thing. But yeah, and then if it does both here, because if it's just a 4-cell module, so without this part, it can obviously then do both ends, because it's got both on that one, and then it's got the intermediate points. So effectively it only needs to connect to the start and the end, and then to each sort of buzz bar link. So this is for this one, for these 2 points, and that one is for these 2, and that one's for those 2. So hopefully that's interesting. I'm going to get the car moved shortly, and the next video will be the repair. So all right, I should also add that I am high voltage trained. So obviously don't try this at home. I don't think anyone would particularly, but yes, I'd rather if you didn't. All right, take care. Cheers. Okay, you've got the car on the concrete, just getting set up, and yeah, we'll get going shortly. So I've got some spare circuit boards. These are 2 that are left over from when I bought a whole set out of a battery pack, because I work on these cars quite a lot. So there are 2 that are left. I've got a couple here which, according to the label, need testing. One's been attempted to be repaired, but I think it had an issue, so another repair was attempted on it. So I'll probably give them a test while we've got the battery out and just see what happens. Got my high voltage gloves, because obviously we're going to be working within the battery pack. We'll obviously take out the isolator. So there's an isolator which actually splits the battery in half. That orange thing I showed in the previous video, but it's still high voltage. And this is a lead I made up specifically for these cars. So because I'm working on the floor, it's a kind of a pain to push the battery and lift it up and get it plugged in and then see if it's fixed, especially if you test things like I kind of do, or test different sort of repair methods, different stuff like that. So I basically made up this lead. So I've got the connectors off a scrap battery pack, and the connectors off the car side, and I made up this couple of meter lead. So basically when I've got the battery out, so I've got the battery here, I can connect it to the car, and I can use the diagnostic machine and see if I can read all the voltages, see if the circuit boards are all happy, do any sort of like not coding, but yeah, just kind of get it all to work and check it's okay. And then we'll put the lid back on, bolt it all down, move it over. So just to save a step, because I've worked on quite a few of these cars, so that's just a big bit of labour saving lead that I've got there, so you might see that. So yeah, all right, let's do it. Okay, so the battery's out on the i-miev. Something that's really interesting is this has definitely been out before. So I mean, big telltale, this earth, well, other than the fact that it's meant to be kind of clipped in there and on there, so it's actually like an earth for the lid, it was squashed, so it's been kind of crushed there, which is interesting. Yeah, and then if you look at, so just in here in the isolator, there's meant to be 4 bolts in there that hold the lid sort of firmly onto the isolator, which are not there. So yeah, kind of interesting really. This has definitely been off before, and the underside of it looks really in good condition. I don't think the pack is new, but I think it's had its recalls done. So there was a recall on the bars underneath, as I mentioned, and that's been done. So I mean, like, here's a pretty big telltale that not all the bolts have been put back, so someone's been here before, but that's probably not surprising given the age. But maybe it's had a cell replacement or whatever. But I guess we get the lid off and find out. All right, cool. Okay, sit rep. So basically, my spare boards are no good. So I had 2 that I thought were from when I bought a whole set out of a pack from a sort of battery recycling company that use them for sort of second life home storage and stuff like that. And actually I only had 1 left from them, and that one had slightly fluctuating readings. I did get it to show the level of charge on the dash and that, but it wasn't totally happy. But I thought, I'm not happy with that one, swap it to the other one, and I think the other one, which I thought was from there, is out of another car and is a failed one. So basically I've got a lot of failed boards, so I currently haven't got a good spare. I've contacted a parts place at an EV garage to see if they've got one, or if not, I will have to get some of these boards repaired. It's not always successful, but basically if I repair all my failed ones, then one of those is going to work, basically. So one way or another, we'll get this back together, but there's going to be a slight delay. That's the way it goes with used parts. All right, catch you later. Okay, so there's been a slight delay because I've been on holiday, but we are back. We have got some more parts. So we've got 3 boards. So quite some time ago I bought a whole set of circuit boards and split them with another guy. He's a bit of a legend in the sort of EV repair world, Pete Melville. If you're a member of Hevra or you've sort of been around EV repair circles for a while, you'll know Pete is a really nice guy, and general all-round legend. So yeah, so he still had some boards spare, so he sent me his spares. He's not doing much in sort of parts nowadays, so yeah, he sent me all his spares, which is 3. Slightly amusing story, slightly annoying story. He keeps everything in a storage container, including these. So he went to the storage container, got them. He's got loads of parts, sort of broken parts that he's tested, some good parts, just kind of, he keeps everything there, just a shipping container. Went and got these for me, posted them over to me, and I've been on holiday. And then he went there the last couple of days, and the padlock wasn't on the container, and he thought, oh, okay, someone's been in here. Open up the door, totally empty. The whole shipping container totally empty. It looks like there's been some kind of miscommunication with the storage company, and they've basically emptied the container, and it looks like they've thrown everything away. So these have been saved from the jaws of the skip, potentially, and it's kind of really annoying because some of the parts, they're not like mega valuable. We didn't pay a fortune when I bought this whole set, but they're just really hard to get hold of because there's not a lot of these cars and lots of the other parts. Sometimes you get a load of parts from a vehicle, one might be faulty, but you might use another small part to fix a car, or you might just send it to a garage just to try this, like we know on this unit. So some units do multiple jobs, like it might be a combined DC-DC converter and motor controller together, and a garage might have one with a faulty motor controller, and we've got one with a faulty DC-DC converter. You just put it on for test purposes. Do your fault codes go away? Do they change when you put this unit on? So your fault code's clear, and the ones that we know that this unit has come back when you put this on, but you don't get any others, and it just proves the faults in that unit. Or maybe you can use the, you know, maybe you can take the good bits of those units and make a working one kind of thing. All these, this is kind of the stuff we do, but we do it on the basis of having a container full of parts, and that stuff is potentially all gone. They're trying to work out sort of where that is and whatever. But yeah, so anyway, a little bit of a shock when I had that conversation, but here we are. I'm just getting the camera set up for the time lapse, and we've got the boards, and yeah, let's do it. I guess little recap, if you've joined at this point, this is a 14-year-old Mitsubishi i-miev. It's got a battery pack fault, high voltage fault. I bought it, it's done 27,000 miles, that's really low mileage. I've worked on lots of these cars, they're immensely fixable, and just kind of to prove that EVs are fixable, this has got a battery pack fault on one of the circuit boards, one of those boards inside the pack, but this can be fixed. This 14-year-old electric car is going to get back on the road, if at all possible. So let's do it. Okay, so little mid-repair update. We're actually getting somewhere. So I had to try a couple of different circuit boards and getting them sort of programmed into a set to all communicate with the BMS has been a bit of fun and games, but we are getting somewhere. So we've now got the battery gauge showing, and also the high voltage warning light comes up about there, has gone out. It's got the ABS lights on just because I've done a scan with the diagnostic machine and that. That does that basically. But yeah, so what that gauge means, the fact that it can show the battery charge level, is that the car's getting a valid signal from all of the battery monitoring. It's kind of happy with everything, and it's happy to show us we've got 2/3 battery, which is cool. And if we look on the diagnostic machine, we've got module 1, so we've got all reasonable voltages, and then we get onto module 2, and we got those there. And before, these figures were kind of all over the place. And just for sort of testing purposes, I've been swapping around module 1 and module 2 and just basically making sure that everything's definitely happy, rather than getting it all back together and finding we've still got an issue. One little bit of fun and games. These things always happen. So you can see we've got a captive nut there. There should be a captive nut under there, but when I undid it, it dropped down out of its little plastic holder. So I'm going to have to take this module out, I think, and then just retrieve that nut, because you don't want anything metal sort of floating around in the battery pack, and obviously we need a nut to hold the bolt on that holds the bus bar on. But yeah, it's all good. So right, we'll crack on. Okay, so the car now starts and drives. We can put it in drive, and away we go. Let's just focus that. Sorry, it's a little sort of end of the day today, so there's low sun. But yeah, it moves. Brakes sound terrible, which is not a massive surprise, because it's been sat for a long time. So at the end of the time lapse, once the battery was kind of in and the wires high voltage wires were connected, I had the car, I just left it running, and that's the best way to check whether things are kind of good, because if it gets a skew reading from the battery, it'll shut down. The car was still in ready, but the warning light came back. So drivetrain warning light came back. And the diagnostic machine says cooling fail, something to that effect. Cooling system fail. It's not, that's not inside the high voltage battery. That is, there we go, stored now, but I suspect that will become active again. I suspect that's probably the water pump for drivetrain cooling, because I haven't heard that kick in. But that's just a standard water pump. The car starts and drives, and to be honest, I'm totally exhausted and I'm done for today. I will catch you later. Okay, so car update. So it consistently starts and moves. It charges. It's currently on charge. So the cooling fault code, it was just really low on coolant. So basically what happens, it doesn't have a coolant level sensor. You can hear it's running. It doesn't have a coolant level sensor, but if the coolant is low enough, when it commands the pump just spins really fast. It goes over speed, and then it knows that it's pushing fresh air basically, or like the impellers come off the pump or something like that. So basically put a load of coolant in it. It was about half full, and it's charging happily. I charged it because it runs a coolant pump more often when it charges basically, so just to make sure that the warning light doesn't come back. It may be I wondered if it had a coolant leak, but it's probably related to all these bolts were undone, because this is the onboard charger, and it's quite common. That's probably the most common failure on these cars, is the charger. So someone probably thought, oh, the battery's just flat, maybe the charger's failed or whatever. So all those bolts are undone. So whether they drained the coolant to, you know, thinking of taking this box out. But either way, I put coolant in it. The coolant hasn't fallen out. So it is on charge with the Type 1 charger. This is just a quick test. I've got it on an extension lead so that I can kind of monitor it. It's a slightly dubious charger because it's actually a 13 amp charger. The early ones of these come with these 13 amp chargers. Later cars and all granny cables, recent ones are only 10 amps because 13 amps is quite a lot on a 13 amp plug with a 13 amp fuse. But because the batteries are quite small in these, it doesn't actually charge for that long anyway, so it kind of works. Basically, it's full before anything melts. But yeah, just on here you can see it's drawing 11.8 amps, so just to prove that it is working basically. But yeah, that's getting a little bit warm, so I'm going to unplug that in a minute. Yeah, so just kind of testing everything in the car. The heater works, the aircon didn't come on. Not a massive issue at the minute, but it does use the aircon for battery cooling. So it's actually got a flap inside the cabin, and when you CHAdeMO rapid charge, which all UK i-mievs have CHAdeMO rapid charging. So yeah, when it starts CHAdeMO charging, as the battery warms up, it uses the aircon system. There's a little fan on the back of the pack to exhaust the warm air, and then there's a flap on the front, and it basically moves the flap in the cabin and pushes aircon air down into the back, which is kind of cool. But yeah, so long term it will need the aircon working, but that's not a big concern at the moment. So yeah, just having a look around the vehicle and seeing what's what. They do suffer with corrosion, these, so you can kind of see brake pipes is one. So we can kind of look through there, you can see it's looking a little bit crispy, so we've got a bit of sun here, but which is not ideal, but it seems to work. They suffer with corrosion underneath as well. This one is not the worst, sort of not the best, but not the worst. We basically see what happens at MOT, I think. Rear tyres look good. They've obviously been replaced fairly recently. Front tyres are terrible, obviously quite old, and then it's sat and they're quite cracked. So I've already ordered a couple. I sort of broke my own golden rule really, because I usually don't spend money on things that don't fix it until it's fixed, kind of thing. But basically they were like 65 quid or something for the pair delivered, so it's like, yeah, whatever, let's save the time. And they come from Europe, so it takes a lot longer, so it's like I'll just get them ordered. You can see this one is quite bald as well, and then it's quite cracked. So yeah, so I've got a couple of tyres. I need to go and see the tyre guy, get those off, take them over to Adrian, get him to pop them on. But other than that, sort of check the lights and things. I think very shortly we're going to book an MOT because that cooling system thing is sorted. Yeah, basically we take it to an MOT and see what happens next. I've sort of started and stopped it a few times. It's consistently happy. Having it on charge is quite a good test, because if there's any issues with readings from the battery, it'll just instantly kind of shut down. So yeah, it's going to plan. All right, cool. Okay, so today's the day. I'm just about to take this car for an MOT. It's been starting and stopping and sort of driving and everything. Okay, I mean driving, obviously it's got no MOT, but I live down a little lane, which is quite cool, so you can kind of go down the lane to the road, spin around and then come back again, so without going on the public road, which is nice. So I've had my tyres fitted, so a couple of brand new front tyres. These were really bad, cracked and everything. Fortunately the back tyres look like they've been replaced sort of obviously not too long ago. They got plenty of tread, which is good. Pair of Continental ones, which is cool. Yeah, some concerns for the MOT. Front suspension, so if we can get in here, you can see these rubbers are not looking too good. Similarly, oh, it's hard to get the phone in there, but sort of there, you know, we'll see. Basically, it is what it is. If it needs work, we'll get the parts. Obviously parts are not that easy to get hold of for a car like this, but if we got to get them, we got to get them. We can order them from abroad or whatever. All things are possible, so we just see what happens basically. Some people kind of worry about, we might get advisories, but it's a truthful, you know, recollection of events. You know, if it gets an advisory, that's about it. Sort of as I said in the last video, really, rear suspension, they do suffer. They're quite exposed. This one's not that bad actually. Some are worse. Yeah, I mean, it's not ideal, but it's obviously been sat for a little while, but we'll just see what happens. All the lights work and everything, so I've done some basic checks. It's obviously got its tyres, and we just put it in and see what happens. So yeah, see you on the other side. Okay, well, I have an update. I have just returned from the MOT station, and check this out. It says pass. So we've got some advisories, massive surprise. So near side front suspension, pin, arm pin or bush worn but not resulting in excessive movement, and same for the offside. So both front suspension arm, pin or bush worn, yeah. Brake pipe corroded, covered in grease or other material, near side and offside. So yeah, basically kind of what we expected, really. Corrosion at the back, yeah, and on the both sides, and front suspension both sides. I mean, to be fair, it's passed, you know. I obviously repair a few cars, so I do get a few MOTs done, but I don't really know the garage where I take the MOTs. It's just literally the nearest one to my house. So, you know, I just rock up like any other member of the public and yeah, and get my MOTs. So that's what it is. The most impressive thing, which I didn't quite realise, I knew this car had sat around for a little while, but just looking at the last MOT, it was last MOT'd December 2020, 27,453 miles, and this MOT is 7 miles later. So in, what's that, 3.5 years, it's done 7 miles. I really didn't, obviously in that 3.5 years, it's driven for some of that, but it's only done 7 miles. So this car has sat for over 3 years, and now it's running again. Yeah, which is quite staggering, really, to be honest. I mean, the brakes are still really noisy, massive surprise. They will clean up, to be fair. There's plenty on the pads, but obviously, because it's an electric car, it does regen when you take your foot off the brake, so it uses the motor as a generator. So you get like braking effects from the motor, and then it recharges the battery, kind of thing. Yeah, I'm sort of slightly surprised, really, to be honest. I was expecting a list of jobs to do, but yeah, fantastic. So in terms of now, what do I need to do with the car? So I was chatting to a garage sort of down the road, other direction to the MOT garage, and they need a courtesy car, basically. So I said to them, oh, I've got this little car, and we had a quick chat about it, and I basically said, well, I'll drop it off to you and just use it for a bit, and if you want it, you can buy it, and if you don't want it, then bring it back, sort of thing. Overall, I mean, like the rear arches, I've seen them with really bad bubbling on here. It's not that bad. It wants a bit of tidying up for the corrosion, but that being done, this should keep running for a while. and because they're quite close to that garage, if they have any problems, I can sort them out for them. So it's perfect, to be fair. A little courtesy car. I haven't obviously tested the range. I've only been, it's like about 3/4 of a mile to the end of the road to the MOT station. So I don't know what the range is like. I did do a full load test, so I put my foot flat to the floor just to load the batteries. And if you get any worn batteries that have high internal resistance, so that means the voltage will really sag under load, then that's obviously an issue. But yeah, that was all fine. It just kept accelerating, all fine. So I need to do a full range test. So I need to go and flatten the battery. I need to make sure that it doesn't break down before it's totally flat. And then yeah, fully charge it and see what happens. Go and get on the fast A road and hammer it and see what happens. Check the range is good and everything, you know, it keeps driving and charging, do a full charge, all that kind of stuff. I've noticed the mat is really annoying. That just moves around. That needs sorting out because that's not really safe. That could get wedged on the pedal, sort of thing. The other thing, so just in terms of things that need tidying up basically, so I can take it to the yeah, to that garage. So it's got this charge cable is a 13 amp one. This being an early car, some of them came with these. So if you buy a 3-pin charge cable now, it will be 10 amps, not 13 amps, because although 13 amps is a max, it's not really safe for continuous use. And basically what happens is exactly what's happened to this one. So if you look at this pin, that's kind of melted, and that'll be because there's a fuse in here. And it's just got hot and it's just melting the plastic, which kind of proves that's not safe. So I've ordered another cable on eBay, just yeah, just a bog standard cable, but obviously one that's not 13 amps, a 10 amp one. But yeah, looking around this car, telltales that it's been serviced. See all the door locks, yeah, have all been greased. So it's been looked after. It's basically been a company car. That's what's on the V5. And then I think a sales guy had it. I think they probably auctioned it. And then the sales guy said, it's like a used car sales place. He bought it with a load of other cars, presumably at auction. He said that he drove it around the lot for a bit, didn't really know much about electric cars, and then it stopped working. So I was like, okay, fair enough. So whether that's totally true, I don't know. It doesn't really matter. But yeah, basically, it works. It's all good. I'm quite pleased. A little bit surprised, but yeah. So a bit of tidying up, and it'll be gone. What I will do is sort of, I'm going to do some man maths of you know what this would cost. So if you have one of these cars and it has a major fault like that and it needs the battery out, there's another couple of other major things that can happen. But yeah, if it needs something like a battery repair, is it actually economically, you know, viable? And realistically, in terms of price, because I was chatting to the garage that might have it as a courtesy car, you know, what is it worth? And I said to him, well, it's a couple of grand, you know, yeah, sort of 2 grand, something around there. I had 2 of these about 3-4 months ago, and sold them, so I kind of know one was nicer than the other and stuff. So I've sold some of these recently, so that's about the money. This is obviously older. This is quite an old one, but then it's quite low mileage, so you know, it's a little bit swings and roundabouts there. But yeah, so whereas I used to fix these, well, I fixed these for the last few years, 3-4 years I've been doing these ones, and I used to sell them for like 4.5 grand, so like kind of just after COVID effectively. So yeah, they've really gone down in value, but that's because better EVs are available, which is great, and these are cheap, which is cool. It's just where it is. So, but what it means obviously is, you know, repair costs don't go down. If anything, they go up, obviously. So yeah, I'll do a bit of man maths, and we'll do a little video on that. But yeah, there we go. There it is in black and white. So yeah, I think I need to tax it now because it's got no tax, but I can do that now. It's got MOT, and yeah, it's all good. Right, catch you later. Okay, guess who's back again. Right, so the little i-miev, the 14-year-old i-miev that we fixed a couple of weeks ago, has got another fault. I've been driving it round. I mean, it's occasionally not starting, and I've been having to clear a fault with the diagnostic machine, and basically it's what's called a pre-charge fault. It's the classic P1A15, which these cars get. We've seen quite a few of them, done a lot of work on it, and yeah, it's quite interesting. Although this is quite an obscure car, lots of the fundamental EV architecture is the same as you get in any other EV, basically, or nearly all other EVs. So it's still kind of interesting and really relevant to sort of brand new EVs today, basically. So what is happening with this car? So it's an issue when the car switches on. So under the boot, and obviously in other vehicles, these things are in different places. So this is the onboard charger DC-DC converter, and this is the motor controller or inverter, okay? Happens to be in the back in this car, but all cars will have a motor controller because they have three-phase motors. You've obviously got a DC battery, but you've got a three-phase AC motor, and you've got to change the DC from your battery into AC for your motor. So within that motor controller, there are capacitors. Now, if you've ever played with a remote control car or any kind of RC vehicle, when you connect the battery, there's a little pop, a little spark, okay? And the reason for that is that there's capacitors inside the motor controller on your RC car or whatever, plane, and there's this little inrush of current, a really small amount of power, but it just all comes at once because the capacitor can soak that power up really quickly and it wants to charge, and that's what they do. And the same happens with cars, okay? So they have capacitors inside these motor controller. They're a bit bigger than you'd find, you know, kind of in your RC car, but pretty more like that, or it could be a bank of smaller ones, but something of that magnitude. So the same thing would happen with a car in that when you turn the battery on, so the battery's got big relays inside called contactors, but fundamentally they're just big fat relays, we just call them contactors. When the battery turns on, because it's obviously not connected all the time because it's 350 to 400 volts, or in newer cars up to 800 volts, that's obviously not connected all the time, so it's switched off by relays in the battery pack, relays called contactors. So the battery's off, so we've got to turn the battery on, and we've got to close those contactors, close those relays to connect them. Now, if we just had two relays, one on positive, one on negative, and turn them both on, we'd get a spark every time. The spark would be big because the capacitor is big, and that would mean that those contactors, the relays, would last about 5 minutes because they would get pitted and they would weld themselves closed. So that's no good. So cars have what's called pre-charge, okay? So they have a little like warm-up sequence to bring the high voltage battery on. And what happens is, as well as having a positive and a negative contactor, and we're not talking about charging contactors here, okay, charging relays, we're just talking about the ones you need to connect the battery and turn it on, okay? The main relays. So you've got a positive and negative, and then you've got an additional positive. And what that is, it's connected to the same places, so it's connected to the output wire of the battery, and it's connected to the battery cells, but it goes through a resistor, a pre-charged resistor, and that is just a quite a high wattage, sort of 20 to 30 ohm resistor. And what that means is when the car starts, it turns on the negative contactor, negative relay, then it turns on positive pre-charge. So it's turning on positive and negative, but positive is going through a resistor, which just allows that trickle of current just to come through and charge up the capacitor. And then if the capacitor gets to close enough to the battery voltage, then it will turn on the main positive contactor, so the one without the relay, without the resistor, and turn off the pre-charge one, so that you've then just got positive and negative directly connected. And then you avoid that spark, and the car monitors the rise in voltage of the capacitor inside there. And as long as it gets to the battery pack voltage within a set period of time, then this sort of start continues. You know, the main positive will come on, pre-charge positive will go off, and then the car's running. And what this car is saying is that it thinks that the rise in voltage of that capacitor is not high enough, it's not close enough to battery pack voltage. So when it closes, if it was to close the positive contactor, main positive contactor, there would be a spark. That's what it thinks. So there's a few things that can cause this, generally speaking. One could be like a drain on the high voltage system. So let's say your air conditioning compressor's got, you know, moisture in it, and there's a link between the positive and negative. when the little trickle of current goes through the pre-charge resistor, that's going to get drained away, isn't it? It's going to get, you know, that moisture is going to be a load effectively in the AC compressor, and pre-charge is not going to get high enough. So that's the kind of things that can happen. I've seen it before on this car lots of times. And what it actually is, so we said the car needs to monitor the voltage rise of that capacitor. Now on these cars, there's an issue with the measurement circuit, and they become inaccurate over time. So inside here, it's measuring the high voltage system. It's measuring the voltage of that capacitor, which is directly connected to the high voltage system. So on here, actually, you can see these are all a bit grubby, but there's 2 wires there and 3 there. So those 3 go to the motor. It's got a 3-phase motor. And then those 2 come from the battery. So that is effectively connected across those wires. So, whoop, don't lose that. Yeah, the car has got to measure this and report it back to the main ECU. So you've got a high voltage and you've got to measure it and report it onto the low voltage system. So you've got a link there between high voltage and low voltage. So if you think about this, the car's got to measure it, but it's got to keep those 2 things isolated, because you cannot have a link between high voltage and low voltage, okay? Obviously for safety reasons. So there's quite a complex circuit to measure that and isolate it as well, okay? And that's where the issue happens, basically, within that measurement circuit. So let's just have a quick look at the diagnostic machine. So we can see here, if we make that a bit bigger, I can do that, there we go. So we can see here, this is the rise in the voltage of the capacitor in the motor controller. So we can see it's going up, but if we look at it's getting to 342 and the battery voltage is 352. So it's getting there, but it's not quite close enough. And that's classic for these cars in terms of it being a measurement fault. Yeah, so what we're going to do about it, basically. So this is quite useful because where's my chip? Oh, there it is. I have got a chip and a circuit board, which is this one, which replaces the measurement board within this controller. These chips used to be blue, and you can't get the blue ones anymore, basically. So, and I do this repair every now and again, probably every couple of months or so on. And I haven't actually tried out this black version of the chip. Apparently it is a drop-in replacement, that's what I've been told. It's actually slightly cheaper, which kind of helps. Yeah, I've never actually tried it, and I don't want to try it obviously on a customer vehicle first and then a garage get it back and it doesn't work. So actually this is kind of perfect timing, because I can fit that chip and we can check that works, and then we should see a more accurate voltage reading from the capacitor recorded by the car. So we've done diagnostics and we've actually measured the voltage directly on the high voltage system, and we've been able to see that there's a difference between what the car measures and what's actually there and all that kind of stuff. So we've done all that diagnostics in the past. Yeah, so basically I need to open this box up. The circuit board is at the bottom. I need to fit that. It's really fiddly soldering, but it's all doable. I should shout out Greg Fordyce, who developed this circuit board specifically for, well, the early version of this chip, but it's still the same sort of physical dimensions. He's from a company called Go EV, I think it's called, sort of Scotland way. Yeah, and he developed this circuit board to fix this fault. I kind of get the feeling he's a bit like me, and he spends far too much time fixing obscure faults on uncommon cars. But yeah, much appreciated, Greg. And we fixed quite a few of these and fixed loads of cars, so it's really, really good. So yeah, so fiddly soldering next. So I hope that was interesting, a little bit of theory there. Yeah, we'll get this car fixed again. Cheers.